You open your video editor, build your timeline, and hit export, only to hit a paywall. Basic transitions and resolutions that were free yesterday suddenly require a premium monthly subscription. But the financial cost is only part of the problem. Behind the scenes, closed platforms routinely scrape your raw, user-generated footage to train their proprietary AI models, burying the permissions deep within their terms of service. OpenCut provides a direct solution to both issues. It is an MIT-licensed, open-source video editor that runs entirely inside your local web browser. To run it locally, you need 3 specific prerequisites: at least 2 GB of RAM, Docker Desktop for the background services, and the Bun JavaScript runtime. By abandoning cloud-tethered ecosystems and self-hosting your software, you keep your data isolated on your hardware, removing the risk of third-party harvesting or arbitrary monetization traps. Step 1 is securing the local environment. Open your terminal, clone the primary OpenCut repository, and create a file named .env.local to hold your configurations. This mockup shows the exact command you need to run next. Use OpenSSL to generate a 32-character cryptographic string and paste that exact string into your .env.local file to secure your local user sessions. Do not skip this key generation step. If the application cannot locate this precise 32-character string, authentication will fail and the editor will crash immediately upon launch. With the security key in place, run a single Docker Compose command in your terminal to launch the database and caching microservices. This architectural flowchart illustrates what that command builds. The central server node connects to a Postgres database storing project metadata and a Redis cache handling local rate limiting. When both the database and cache blocks pull screen, you have established a healthy, live connection. You now have a fully isolated backend infrastructure running on your machine, completely severing any reliance on external third-party servers. Step 2 is compiling the front end. Run bun install to fetch the workspace dependencies, and then execute bun dev web to boot the local server. Once the terminal confirms the server is active, open your web browser and navigate to your local host address to load the interface. OpenCut organizes its timeline using what it calls scenes. A scene is a self-contained, independent timeline, allowing you to manage distinct video chapters without them interfering with one another. Import a local media file from your hard drive into the media bin and drag it directly onto the active timeline. The timeline supports 4 distinct track types: video layers for footage, audio layers for sound, text layers for captions, and sticker layers for graphics. This cross-section diagram demonstrates how those tracks interact. The vertical stacking order determines the z-index rendering priority. The layer at the top of the stack will obscure the layers beneath it in the final visual preview. Because this editor operates entirely within a web browser sandbox, it faces physical limitations, specifically JavaScript memory caps and the processing overhead required for garbage collection. Attempting to stack dense, uncompressed 4K multicam clips on a single timeline will quickly overwhelm the browser's memory allocation and crash the application. Managing how the browser allocates local memory allows you to build complex projects without reaching these performance ceilings. Step 3 is the export. Once your sequence is complete, trigger the rendering process. Note the current technical constraints here. OpenCut relies on 8-bit color quantization, meaning it cannot natively support the uncompressed 10-bit color spaces required for cinematic post-production. Instead, the application utilizes WebAssembly and WebGPU to process millions of video frames directly on your local hardware, entirely offline. This logic chart tracks the system export process. On the left, the local rendering progress bar fills up. On the right, network traffic remains flat at 0 megabytes per second. Locate the generated file. You've exported without uploading to the cloud. By migrating the entire rendering pipeline to the client side, you retain complete sovereignty over data, ensuring immunity from corporate scraping and subscription paywalls. Next time, we will explore OpenCut's headless mode and its model context protocol, allowing you to use AI coding agents to automate your timeline editing workflows entirely through text commands.